Oops, you can't hear me. That's it, there you go. Hello there, hello everybody. Thank you all for coming. I know it's about 2 o'clock in the afternoon and it's a dark room and I've got one of those voices that probably sends people to sleep. So I will try my best, but Richard has very kindly offered to help facilitate the session. So any questions, please feel free to ask me at any point. Richard's the gentleman with the microphone.
Yeah, so we are recording this session, yes. And I don't have the sleep-inducing voice. I have the loud. I'm doing my best American impression. I'm actually a Canadian. So I will run the mic to you so we make sure we get your questions on the recording so it's valuable for everybody. So if you just throw your hand up or make a gesture at me, I will come to you.
Yeah, it sounds good. Now, I should say that the lights are really bright in here, and I feel a bit blinded. I can't see everybody. So if you wave at me frantically, then I'll hopefully see you. And if not, nudge the person next to you. And eventually we'll have a Mexican wave, and I'll catch you eventually. So what I wanted really to talk about was it's about really trying to help you guys to use your existing business intelligence skills and expertise and use those for analytics. Now, I don't know about you, but when I look at the Microsoft keynotes and they do things like connected cows and all this wonderful Power BI stuff, I think, wow, that looks great. But I spoke to a lot of attendees yesterday who said, actually, that feels unattainable for me. In my environment, I don't have all of that set up. I'm just trying to muddle along like everybody else. And so I think that's why this session is relevant, because I'm sure you all probably are thinking, well, how can you make analytics relevant? I don't know if you feel that, but I certainly do. So if you want to have a problem about how do I deal with analytics, how do I make it relevant, how do I learn this stuff, then you've come to the right session. That's what we're trying to handle. Because the idea is really about letting your data surprise you. This is Chris Hadfield, another Canadian, in the ISS space station. Now, the world seems to be absolutely full of data at the minute. Data-driven leadership is all the rage. It's all of our phrases. But what I really personally love about data is its ability to surprise us. Now, we all have data in our organizations. So who here has a data warehouse, has built one, uses it? Probably most of you, that's right. And probably those data warehouses, particularly if you've built it, is a very critical place in the environment and your organization. Plus, if you've crafted that, you know that data warehouse inside out because you've built it. You know the ETL, the packages, the data. Now, what we want to do actually is, I should say that in business intelligence, it's still very much a sphere and it's still very much around. But you can use your existing business intelligence solutions and then leverage those towards analytics. Now, a word of warning, you think business intelligence is difficult to implement. Now, the Gartner studies show that 21% of BI projects will succeed. Now, that's, as an industry, our adoption rate is really terrible. Now, I think the reason for that is the users don't have the ability always to be involved in the project. And then the project is supposed to be for the users, and they end up not being part of the process. So certainly when I've built BI solutions myself, I put the user very much front and center of the project. I've seen projects fail. I've seen projects fail maybe after having going on for 2 years, and they failed because the users were not part of the process. Now that's BI. Now, business analytics is also difficult. It's difficult to implement. Now, there's a number of reasons for that. One is it's very difficult to show return on investment for BI projects. It's even more difficult to do it for analytics projects. The way I try to look at it is business puzzles versus business mysteries. Now, I assume everybody knows the Enron scandal a few years ago. I don't know about you, but I remember those poor people walking out this big building with big boxes of paper. Do you remember that? Those poor people. So the problem at Enron was not that they didn't have enough data. The problem was they were drowning in data. They had data over data. They had lots of tools that would help them to look at business puzzles. A business puzzle is a very well-defined question with a very well-defined answer. What were my sales for the last year for a particular product in a particular region. Now, if you go to Excel, you can use a pivot table. It will give you that. You can do reporting services, use a parameter. That will give you the information as well. Those are puzzles. And it can be hard enough to provide return on investment figures for those sort of projects. But for analytics, you're not asking those questions. You're asking questions which are not well defined and don't have a well-defined answer. I'll give you an example. I did some work for a mobile phone firm who will remain nameless, but they were interested in who leaves us and where do they go. Now that sounds a deceptively simple marketing question. It's actually really hard to try and work out, okay, so these people were using, say for example, Windows phones, where did they go after that and why? So it turned out, obviously, a lot went to Apple, so probably most of you have an iPhone, but also Samsung as well was another opportunity. People were moving from one to Samsung. So the problem is it's very difficult to start defining the questions until you've got some sort of answer. So you're sifting your way through all of this data. So I think business analytics can be harder to implement, and that's why. You don't have well-defined answers and well-defined questions. You don't know what you're looking for. It's a bit Donald Rumsfeld, his unknown unknowns, that quote. It's a bit like that. So business intelligence is what you need in order to run your business. These are the figures which basically mean you can conduct your business, you can drive your business, you can also get your data, your workplace legitimized, you make sure it's audited, for example. But business analytics are really needed to change the business. Now, there's a gentleman called Andy Groves who ran Intel for about 30 years. I mentioned him, he died just a few months ago, an incredibly clever man. Now, he steered Intel through 3 decades of change, going from a hardware firm to trying to diversify and adapt to the market. And he talked about pressures on the organization. There can be internal pressures, such as from your employees, your products, changes, research and development. You also have external pressures as well, what your customers are telling you, what the environment is telling you. So when an organization has equal pressure, they're in equilibrium. And the internal pressure and the external pressure is about the same. But what happens is at some points, your business needs to pivot. It goes through an adolescence. So who here works for a small organization? A kind of startup, a few of you. Okay. I find sometimes when I work with small organizations, they tend to start off very small. There's just 1 or 2 people, and then people empire knowledge. It's a bit like the Spice Girls. You've got the one that does the database, the one that does IT, the one that does, so you've got people who do different things. Then the organization starts to change because it has to, and that model doesn't scale very well. So it goes through like a sort of icky sort of adolescence, right? So it has to go from a small organization to a medium organization. And that's the point things get tricky, because you've got these empires people have built and you have to try and break them down again. But the one way you can do that to make sure at that point you're going in the right direction is to look at business analytics. You're trying to predict what's going to happen next. So it's always a risk, but sometimes it's a risk you have to take. If you get the chance to read Andrew Grove's novel, his book about it, I've forgotten what it's called, I recommend you do. It's really interesting. Okay, but business intelligence is like your rear view mirror. It's what happened yesterday, okay? You're right up until the last point at which your data warehouse has got data in it. Business analytics is trying to work out your next step, what's happening next. So it can be perceived as very hard analytics. Now, what I want to do is I'll give you a demo. I want to show you some R. I want to show you some Power BI. And I want to show you how R, SQL, and Python are actually got this very similar commands. So who here has written a SQL statement? All of you, absolutely. Now, that means you've got a great starting point to learn R and to learn Python. You've already done a lot of the hard work. You've learned a lot of the constructs. I'm not going to show you all strings of R code and Python code. I'll put this in my blog. I want to give you enough that you can look at it and say, right, so that equals that. Right, I know what I'm doing with SQL. I can do the same in R. And when you get commands running in R, it's actually enormously satisfying. And it means you can also check your customers as well. So I was dealing with a customer, and they said to me, can you just, here's some Excel spreadsheets. Let me have a little look at them. So I think, okay, I'll look at those. And I see a mistake, and I can't help myself, you know, because I'm that sort of person. And what they'd done was they'd got the median, and they'd calculated the median incorrectly. I know you're looking at me thinking, well, how can that be possible? Because the median's super easy, right? All you do is get your data, put it in ascending order, pick the middle one. So what happened was in Excel, they were not using the median command in Excel. What they were doing instead was taking the big column of data and choosing the middle cell and saying, that is the median. And I looked at it, I had to check myself. I was thinking, is that right? So I'll go and ask them. Because I said to them, every time you change the columns next to that, that figure's going to change. If that's in column D, then you filter by A, B, and C, you get a different number. Or if you really filter, you'll get nothing, because that data will disappear. So it turned out they had tried to calculate the median. They didn't know what they were doing. So I don't know why. They decided that they would go for that method. So I showed them how to calculate the median in Excel, and they were embarrassed because they've been doing it wrong for about 2 years. So the thing is with analytics is a lot of it's very basic. And if you have a great starting point by looking at descriptive statistics, you'd be surprised how much you can tell about data doing descriptive statistics. So here's a takeaway action for you. Next time you're in your data warehouse, just go and look at the minimum amount, look at the maximum amount, and just look at the average, the mean. The reason I mention that is I did some work for the NHS in the UK, and I did a min and a max. I mean, it was easy. You know, we can all do that in SQL. Now, it was number of bed days, and it turned out some of the patients had spent minus 189 days in bed and taking up a hospital bed. And I thought, well, how can they take up minus 189? And that was the minimum number. There was lots of negatives in there. And it turned out the doctors and the nurses had changed the admission date and the release date around. Dead easy to do. And if they're in a hurry, they've just done the wrong thing. But I could capture that dirty data just by doing a min and a max. And they thought I was a genius, right? And I just wasn't. I just had done some very basic checking. So I think by knowing a little bit of statistics, just as a starting point, will give you you'll be that person, you know. So I'm like this in the workplace. People see me coming, and I can see they've got that look on. They wonder what's happening next. So if I were you, I would learn some. It doesn't mean you forget about your BI. I usually get the question, okay, so I'm using everything in SQL Server. Can I just throw that out now? I don't recommend you do that. I recommend you use what you've got in your systems already, and you'll get insights from doing both things. You'll get insights from your data warehouse as you are now, and it'll allow you to go and check what's in there already. And you can be that person who's saying you're calculating the median incorrectly. So how do you get started on this? Well, there's a methodology which I want to point you at called the CRISP DM methodology. Now, if you take one thing away, I would take that away. There's a PDF you can go and download. It's free on the internet. It's done by a company called the Modeling Agency. They're not modeling like, you know, some fashionistas. But basically, they break the process down into 6 phases, which you see here. One is understanding the business. Now, I had a customer ask me about neural nets. They said, I want a neural net. And I said, well, what for? And they said, I don't know, I just know that I need one. And I said, so I had a long time to educate them to say, yes, I could spend some time writing you a neural net. But what does that give you? It just means I've billed you for something you don't need, and I don't want to do that. It's not right. So then you've got understanding the data. That's where the issue comes in, around the median and the min and the max. Just try and work out what that data is. And then we've got data preparation. That's the nasty stuff that nobody likes to do. We always see data which is clean. We always see data in a nice CSV format. Anybody who has tried to put data together in Excel knows that that is a nightmare. It really is a nightmare. It's a horrible job. Then we get modeling the data. Now, there's lots of information in the internet about which one to use. It really comes down to what objective do you want? Do you want to classify your data? Do you want to predict? If you want to predict, look at something like regression. All that's doing is taking some data and trying to predict the next step. I can point you at a flowchart that will help you to decide that. And then we've got evaluating the data. Now, that's extremely important. What we do there is we evaluate the model we've created. We test it. Now, I don't know about you, but when I'm devising projects, I tend to do 50% build, 50% test. And when people work with me on my team, I tend to go in as a technical go-to, and that's how I split up the project. And I tend to be the person who will then go and argue with the person holding the budgets to say that that's the right thing to do. Because we have to test our model, and we keep testing it. It never dies. It's one of these things you have to keep doing it. The reason for that, it comes back to my earlier point about Andy Grove's book. When he talks about internal and external pressures, we all live in a very dynamic data environment, and things don't always, things come at us that are unexpected. So I don't know if there's any questions at the moment. Otherwise, I will move on and I'll show you a demo. All right, okay, thank you. Now, I'm sorry, I'm going to have to put some distance between us. They've put this table up here, and unfortunately that means I disappear behind it because I'm about a meter high. So everybody, when I come to the US, everyone looks really tall. I'm the tallest female in my family, can you believe that? So I'm going to put that there. One last thing I wanted to show you actually is when we split up our diagnostics, split up our analytics, we want to show, well actually, descriptive analytics is all about what has happened to date. Diagnostic analytics is still business intelligence. It's trying to work out what will happen next. That's the interesting thing. So that's where technologies like Cortana and Power BI start to come into play. Power BI straddles both. Cortana is more about what will happen next. And then prescriptive analytics, how can we make it happen? Now that's from Gartner. So if you get the chance, if you can Bing search for Gartner and their analytics definition, that will come up. I will put this in my blog as well, a blog at jenstirrup.com. I'll make sure that you get that. But the idea is that once you start to split up your analytics, break it down into what question am I fundamentally asking, then that helps you to understand which tools to use. I've just got some sample questions here. So business intelligence will ask you something like, how many customers visited last week? And that's quite a straightforward answer. How many people did we get in the store? Business analytics will ask, how many customers are we likely to get this week? Now, people tend to confuse likely and they will confuse likely with probably or possibly. So it's possible I could be standing here in a Santa Claus suit, right? But is it likely? The answer is no, obviously. And I look at, sometimes you see politicians do this. They present something that's a possibility as a likelihood. And then you start to think quite critically about what questions am I trying to answer here. But business analytics is about likelihoods. It's very hard to get certainties. And I think that's the issue. And that's why it makes it more confusing, I think. So BI might ask something like, when did customer X last visit our store? Business analytics will ask the question, what's the probability, the likelihood that customer X will visit the store again this week? So it's much more fluid, and it's not black and white at all. There's lots of grey in there, and I think that can make it a bit more difficult. So I do want to show you a number of analytical technologies. These are really things which are all about getting you started. And these are all options. Now, they've only given me 45 minutes, unfortunately, so it will be a whiz tour. But I'm really hoping that it gives you some ideas how you can make this relevant for your own organization. So the first thing I want to show you, I'm just going to come out of that, is the Microsoft R Showcase. So I'm just going to swap my screens over, at least I hope I am. Joe. Sorry, I'm trying to make sure you can see my screen. So that's hopefully it's coming through. Hi, thank you. I'm just trying to duplicate. Can I do that? If not, I'll just extend and then.
That worked.
Hey, good, excellent. I can't see my screen now, so you'll have to bear with me.
Is this guy on?
Oh yes, it is, thank you. But it's quite, I need to be about half a metre taller to see that one. Oh, thank you, excellent, thank you. That's better. Sorry. Next time I'll come in really big heels. So what I'd like to show you first of all is the R Script Showcase. Now what we can do is these are just examples of data where they've taken Power BI and they have embedded some R scripting in it. Now I'm pointing you at this because it gives you good examples and something you can download and try for yourself. Now, I don't know how you learn. Some people learn by reading, some like videos, some like to write out notes, and some learn by doing, and some learn by breaking stuff. I personally learn by breaking stuff. I break everything, and then I try and fix it, and then hopefully I've learned something along the way. It doesn't always work like that, but I do try my best. So this allows you kind of all of those options. You can go and read about how they've done it. You can also download it, and if you break it, it's not too bad. Just go and download another one, you know. Sorry. So we've got Power BI here. So I've downloaded one of the forecasting examples. So what this is going to do is it's going to it's taking some of the UN data around birth rates and trying to forecast what will the birth rates be in future years. Now, as a visualization note, if you hopefully can see that down the bottom left-hand side, make it big. Now, if you are visualizing data, you need to show a difference between the data that is actual and the data that is forecasted. Otherwise, people, when they visualize, when they are consuming the data you've created for them, they get confused. They won't be able to distinguish what the actuals versus the forecasts are. So that's why we have this slightly grey part here, and it's in red. It's showing you the actual forecast. So if you try, say for example, we do a forecast, and I'm just going to zoom in. So that's the number of births there. And we're going to, this should let us filter. Oops, sorry. Oh, sorry, it just took a little while to catch up. So what we've got here is if I click on North America, it just takes a little while to run, that's all. So I don't know if you saw that there, I'll zoom back in again. But the idea here is that we've got the birth rate forecasted and the actuals up to just after 2012, and then we can see these fluctuations in the birth rates. I'm not sure why that is, I'd be interested to know. But that's the start of analytics then, because you start to think, well, why did that happen and what's likely to happen next? So if we look at Japan, for example, just taking a minute or two to add up. So with Japan, we see we have seasonal fluctuations as well. I'm not sure why that is. Again, it's something that we could look at. So how did we actually create that? Well, what we need to do is a few things. First of all, over in the right-hand side, you see that there's a small palette. Oops, sorry. You see a small palette, and R is in here. So if you are comfortable in using R, what you can do is embed your own R visuals in there. Actually, the way that I started to learn R was by visualizing data. They've got a package called ggplot2, and I learned R just simply by taking some data and trying to make charts with it. That was how I learned to use it. So it helped me to visualize the data in R. I could take the same data and visualize it in Excel. So that was me starting to check, how does this look? Is it correct? And then I could start to, once I'd gone into that formula, I could start to use other packages as well. You've probably heard a lot about R. R's been around for a little while. People like it because it's open source. There are lots and lots of different opportunities to learn it on the internet. One way I recommend that you do that is using the Coursera material. Also, Microsoft have got their EDX facility as well. So there's lots of different ways in order to learn R. So what we can do then is we've got something here in Power BI. And that is all about editing our queries. So let's have a look at our queries. Let's try that one. There we are. So I'm just going to try to pull that up a little bit so you can see it better. So this is the R script, which is copied and pasted into the R script editor. Now, a lot of that's comments, so we won't spend too much time going through it. But basically, it does a lot of things that we already do in business intelligence. So if you think, I mean, who here has used reporting services? SSRS? Yep, about most of you, yeah. So in SSRS, you have a data source, you have a data set, and then you have the report. And basically, SSRS puts those three things together. R is doing the same thing. So this first part of code, you can download this, so we won't go through it in detail. I want to move on to the SQL and R stuff as well. What it does do is it's trying to calculate, goes through the data set, and all it's doing is trying to make the month to be consistent through all of the different rows. Because you know what dates are like in business intelligence. They usually are most difficult things to deal with, and business intelligence relies very much on dates. Analytics does as well. So there's a lot of code in there. And a lot of it is actually to do with appearance. This is a bit I'm interested in showing you. I'm just going to highlight a few things. Now, for those of you who have used something like Visual Studio or something like that, you'll be used to calling libraries. Well, R does the same thing. R has actually got a whole load of packages which you can download from the R website. So you can download those, they are for free. It's a wonderful thing about the open source community. And the idea is if you're already looking at doing something which needs a forecasting formula, for example, you'll probably find there's a package which already has that. So some of these packages are already there in R, so it saves you doing a lot of coding because the packages are already there. So here we've got one called forecast. So what that will give you is it will give you a lot of the procedures, you might want to call them that. They will help you to crunch through the data and then visualize it. So some of this will be very familiar if you've used reporting services. You know, in reporting services, on the right-hand side, you've got the properties, and you can see basically the line colors equal red, or whichever, however you've set them. So this is doing the same thing. It's basically, the way I look at it is exploding the properties in SSRS and just putting them in the script. That's all it is. And when you look at the XML that underlies SSRS, you see lots of this sort of thing. So it's a good starting off ground, I think. Then we start to get down to the actual data that actually does the work. So I'm not going to go through all of these, but you can see here, I think the power of R is basically that it gives you the opportunity to use variables. I think when we start to look at Excel, unless you're using VB or something like that, you've basically got your data held in cells. But what R gives you is the ability to have variables, and it's not like, has anyone here used SSIS? Yeah. Has anyone here used DTS? Has anyone? Now, I'm showing my age by talking about DTS. Now, I remember when people moved from DTS to SSIS. People were upset because DTS was extremely forgiving and it soft-typed everything. And we loved it. I used it a lot. Then SSIS came along and people were shocked. It was as if they said, I have to assign types to my variables? Are you kidding? You know? So I think a lot of people had to unlearn the forgiving nature of DTS and move into SSIS. I'm very glad to say that R is also extremely forgiving. So if you set up a variable, it will work out the type for you. And what's really powerful about R is that variable name can be anything. It can be a data set, it could be a neural net model, it could be a command, it could be some SQL statements for it to go and access data in a database. So the power of R is really all about the variables, and once you've got those in play, then that's really, you've really got to the heart of R. So here's a variable here. Prediction is actually the name of the data set. So if this was reporting services, you would have the name of the data set. That might be usually in SSRS, they call it something like dataset 1. So it's not very imaginative. That's just how it's called. So in SQL Server, the table name would be prediction. That's all it is. So that's what the equivalent is in R, is basically prediction. So when we use SQL, we use the full stop as a delimiter between the column name and the table name. So if we think of our favorite AdventureWorks, we've got production.productionID. R uses a $sign instead of a full stop. So don't be off-put by the $sign. That's all it is. It's the absolute equivalent. So then here we've got the mean. So that's the variable that's going to hold the mean. Now that could be a mean that could be an additional column that you're creating, because R will let you do that on the fly. So when we start to break it down, we can see it a bit more easily. So all we've got here is calculating the last value, and it's going to give us the mean of the prediction value. And the reason it's doing that is here we've got the mean, we've got the upper, and we've got the lower as well. And all it's going to do is take the data point, it's going to work out what the mean is at that point, then it's going to plot that, it's going to show us what the upper band is and what the lower band is. And that means that we can actually plot it. And that's what this piece of code does down the bottom. And I know you're thinking, why would I want to do that? Power BI is really fast. Now, it is really fast, but I've always felt Power BI is a bit like the Spider-Man motto, with great power comes great responsibility. So with Power BI, you have no responsibility. But you don't have a lot of power to change things either. Power BI is not about that. It's about thinking as you go along. Whereas if you want very fine control, people use SSRS because it gives you that very fine control over what you see on the screen. So R does the same thing. But the beauty of R, I think, is it will produce things very, very quickly. Things like box plots. It will just take you a few lines of code. Now, it will produce box plots, it will produce lattice charts, it will produce volcano charts, all sorts of wonderful things. And it does it just with a few lines of code. So if you're a data visualization person, I don't know about you, but I am. Is any data vis fanatics here? Yeah, a few of you. I really recommend you go and have a look at the R. Go and play with it. There's plenty of examples to download. I find it quicker to do it in R than Excel. Once you've got a few lines of code set up, that's it. So we've got that, and I just wanted to show you one last thing. I'm going to go back here. I'm not a fan of PowerPointing people to death, and I will put this in my blog as well. But I just wanted really to give you some examples where you can use what you already know to Springboard, basically from R back to Python. Okay, so I don't know how much you know about, has anyone tried R or tried to play with it? A few people? Yeah, not many. What's about Python? No, that's okay, just one person. Usually I find that's probably representative, that not many people have tried R, and even fewer have tried Python. And that's okay. Now, you're probably wondering what's the difference between R and Python. R is mainly built around the idea of statistics. So if you've come at your data with a statistical viewpoint, then R is probably something you would more lean towards. Now, my background is actually originally psychology, so I learned a lot of statistics there. It's actually much more statistically minded than people might. So then I moved into artificial intelligence, and I was an AI consultant before it was trendy. Then when I found there was I was learning all about these models, but basically it's the same principles. You get data in, you do things with that data, you spit it out again, and then you should visualize it. That's all it is. So with R and Python, Python is more about crunching data. So if you're much more familiar with procedural type languages, then Python is more for you. They're not really competing. Python is more useful for crunching data that's really, really messy. And let's all have messy data. And if you don't have messy data, you're either not looking hard enough. Yeah, everybody has it. It's everywhere. So what we see here is with R, basically we need to install packages, and it's really clear that's what that's doing. Python has a really nice word for that, which is pip. So basically it imports a Python package. Python is much more procedural, R is much more about the statistics, giving you those packages. So sometimes it's useful to know your working directory. You might want to know that to understand where has your output gone. R will dump everything in the working directory unless you. So that's what that's for. I was comfortable with this because it reminds me of Unix days and way back when. So R gives us a lot of opportunities to import packages, make use of what other people have done. So we have something in R called a data frame. It's in as well, and basically that's a data set. It will be your rows and your columns, something you're very used to dealing with SQL. That's all that's going to be. And so what we have here is Python has got something called pandas, and that really helps you to crunch through all of the data. Now, both Python and R have got learning algorithm packages associated with them. And there's a whole wealth of things out there for you to make use of. So there's other things for you to look at there. So we're assigning, I don't know if you can see that, but the capital letter A is our variable name for the data set. Capital A is representing our data set. For R, that's a matrix. And for Python, basically just generating some random numbers, but it does specify data frame, and that's all it is. A data frame just means it's got mixed column types. So one might be an integer, one might be it might be real numbers, it might be varchar. So I've put some SQL in here to help you to see some of the more interesting things that you might use. So say, for example, you look at the third top column, top rows of data. So in R and Python, we've got the concept of head. Now in R, that gives you the top 6K bytes of data. So it just gives you a little tiny bit of it, unless you specify otherwise. I remember this in Prolog, you had to set up the head. It just gives you a chunk of the data at the top. In SQL, that would be select top X from whatever your happens to be, selecting the top number of rows. And in R, we call that the head. So to select the bottom number of rows, in R, we have got the tail. So we've got the head and the tail, but for SQL, we'd probably have to put a row count on it and then reverse it again. Now, the dimension of data, this is an important. I don't see enough people ask about the dimension of data. Now, when we talk about dimensions in BI, normally we think about our Kimball dimensions, our geography, our time, our product, our customer, these sort of things. But a dimension of data in R actually refers to columns you've got and the number of rows. It really means the dimensions or the size of the data frame. Now, it's a very important distinction. So when you see dimensions in R, they're not Kimball dimensions. So don't trip over that one. It's something I had to work out for myself. So the number of columns sometimes is useful as well. You want to know how many columns you've got. I don't know about you, but often I get customers saying, I want a report that shows me 5 years worth of data and it's 160 columns. And I say, okay, so how are you going to mentally process all of that? And they'll say, well, I'm going to print it. Okay, how is that going to work? You use up a few trees, let's say. So sometimes it's useful just to find out the number of columns right from the start. It's a bit more complex to do that in SQL Server. We have to go and interrogate one of the tables, information schema, which tells us metadata, all of the tables. But R and Python make it really easy. We just use the len command. That's all it is. So something we want to do is inspect our data. We want to get a quick summary. So one takeaway action for you is to go and inspect the data in your data warehouse and see what's in there. You might be surprised. So R gives you something called summary. And what that does is it gives you the min, the max. It gives you the quartiles. It gives you the data types for each of the columns. So it reams out a lot of metadata about the columns. And I find that really useful, actually. It gives me a good grounding. I can see straight away what the min is, the max. I've done a little report for the customer. They often don't do this themselves, you see. So in Python, that's a describe command. Oracle also has a describe command. Does pretty much the same thing, reads out the information. Now, but in SQL, you get a nice command that gives you all of the average, min, max, all in one go. We have to do it for each of those commands. Something that might be useful for you is to look at Excel. It's got a data analysis tool pack. It's free. You can download it. I don't see lots of people using it. So if you use Excel to analyze your data, I recommend you download that data analysis tool pack. You should be able to find that. Now, setting the row names, that's something in SQL we don't tend to have. In R and Python, you can actually give the rows individual names. I guess the closest we would indexing. And we can also change the column names as well. And that's quite a useful thing to do. We need to change the column name sometimes to make it a bit more friendly. So that gives us useful information such as the mean, the standard deviation. So a few more of these. So inspecting our data, oh, that's better. So of course, obviously, we need to start to select our data as well. We obviously know what the select command is, select where. We start to use that as a filter. What we can do in R is it uses X and Y. So X and Y will indicate your number of rows you want to get and columns. So that's what that gives you. And you do that in Python as well. So in SQL, we have select X, Y, and that would start to give us select a number of rows, and then the columns, we start to filter it at that point. In R in Python, you can select an individual cell as well. But things is trying to do some of the functions in R and Python. So we don't tend to have these in SQL. We have to go and sit and write them all out. We do get some of them. But you can see, actually, if you want to get the square root of something, it's fairly self-explanatory what you're trying to get. You won't go very far to look for the. If you want to see the square root or the standard deviation, you can see the names are pretty much the same. They look quite good, I think. So data visualization as well. So in Python, in the right-hand side, you just give it one particular line of code, and it will give you the data visualization that you're looking for. Sorry, I've realized that's not right, but in R, we use the plot command. And plot means that R will take whatever you've got in that variable, and it will try to create a plot with it. And it may not look very nice, but that's when you start to add in additional parameters. It look a little bit better. So with that, I'm just going to, I've got 1 minute left. I'm just in nice timing. So I don't know if anyone has got any questions or thoughts. I'll come back down again.
So in that sample you showed, where did you get the UN data from, or the population data?
Oh, right, okay. That's actually a sample. It's a Microsoft sample, which you can download from the internet. So if you look up the Microsoft R showcase, you can go and download that from there. They changed a lot of things in the past few days. So something that was really quick and up to date, really. So you can go and download that and play with it. I recommend you do, because apart from the fact there's something very peaceful about looking at maps, what I find is it means you can break it, download it, retry it again, and just pick your way through it. Hello there.
So the widget.
Hello.
That widget you showed, when you pick one of those other widgets, other R library widgets from the library, is all the code in place and you're just replacing a few variables, or?
You could do it that way, that's right. If you want to start from scratch, there's an R script editor. I'm just going to go back up and show you something, if that's okay. Okay.
It strikes me as very cut and pasty kind of code, right?
Yes,
Like,
it is.
yeah, you get it figured out once, and then you just keep reusing it.
Yeah, okay.
Yeah, so in R, what you need to do is install R first of all. You're right, Richard's absolutely right. It is very cut and pasty, which is good.
Switch over there, Jen.
Oh, sorry. I'll get this up and then I'll switch.
So as a developer, I have to have it, as a developer, I have to have it installed locally as I'm doing my development, and then
Yes.
when I deploy to the web, I'm assuming it's already part of the Power BI service?
It's actually not yet part of the Power BI service, but that's a great question. I wish it was. I think eventually, but at the moment it's just in the Power BI desktop. I would love if they had the R service right next to the Power BI one, so people could use both.
So anything I create, any visualizations I create in R, if I'm to share them with others, they have to have desktop
You have to do
installed
the
as well?
desktop,
Okay.
yeah. I know that's not ideal. I think it will change because R is embedded everywhere. So the development cycle that I tend to do is I have R installed, 64-bit, and then I use RStudio and develop it on that. Oh, sorry, I thought someone's...
So there isn't really a deployment strategy at this point? Everybody has to have R?
Yes, you have to have R. I tend to use RStudio because R, and its own is very clunky. I mean, it makes me nostalgic. That's how old it is.
But it does do the visualizations right there. So,
Yes.
you know, it's as much the development tool as it is the client
Yes, that's
at this
right.
point.
So we have, I don't have a plot up to show you, but if you plot anything, it'll appear on the right-hand side. You could export it just as a picture, or you can share. What I like about it is you can share the scripts with other people. And I think something we didn't have time to cover today was the RStudio. Was actually the Visual Studio now has got R in it. So you could use that as your development environment. I just happen to like RStudio just because it's something I'm used to. I need to go and look at. Yeah, but I like the Visual Studio. I have looked at it, and what I liked about it was the ability to check in code and back out again. I usually find customers have either got no source control or they've got 3 or 4 source controls. I don't know which is worse because I don't know which one I should be looking at. And that's what happens. But that's, I just tend to use that because it's on my desktop. I have it on a virtual machine in Azure just so I can access it. It's just easier, that's all.
Time.
All right, thank you.
Thanks, Jen.
That's all right, thank you for your time. Thank you.